All right, now we're going to get into the eating module and have a few fun fact stories. You don't have to write any of this down, but I wanted to share some fun facts about eating in my personal history. I think I've told a lot of you I used to do a lot of bicycle riding before my accident. And actually, in 1986, after I graduated from Ohio State, before I went to graduate school, I was living in New Jersey, and I took a one-week bicycle ride from New Jersey to the state of Maine. That was 600 miles in a week. But what I most remember about that trip is I set a world's record for myself in terms of number of boxes of Pop-Tarts ingested. I think I actually had like 7 boxes during that week. So that was certainly a moment that was in history for me. I don't think I've ever had 7 boxes in a week. And then number 2, my other biggest bike ride that I remember was in 1988. I took a one-day bicycle ride from Binghamton, New York, back to Edison, New Jersey in a day, and that was 206 miles. And I remember very well that at mile 140 I was getting very tired, found a Burger King, and I think I had a bacon double cheeseburger, fries, onion rings, and shake. And boy, that was really good. But I actually hit my wall after that, so it was a stop at a fruit stand and eating a whole bunch of grapes. That kind of gave me my second wind to get back to Edison, New Jersey, and 206 miles at the end of the day. This has absolutely nothing to do with what you need to write notes on, but I thought it would be mildly amusing. So that is the setup for our unit. Maybe I'll stop this recording. No, I think I can kind of keep going here. So let's keep going, and basically the same idea here. You have an agenda here. You have to type out a good detailed outline, kind of outlining what I share with you acoustically here. So we're going to start with number 1 here, the biology of eating, and chapter 10 will be relevant here. The biology of eating is very strong with this idea that eating is biologically based. There are biological elements in your body that control how much we eat, when we eat, and what we eat. And so the biologically based theories start out in this way, that we know quite a bit actually about some of the basic biology. And so let me share with you some of this. We start with basic metabolism. And if you look at the first appendix, it kind of shows you a picture of this. So basically, basic metabolism, I'm not going to go into a lot of detail, but we have 2 phases, the absorption phase and the fasting phase. The absorption phase, when you wake up in the morning, most of the time we're hungry. There are a few things that happen there. First of all, the hormone insulin is secreted. And insulin is secreted, and obviously then you eat some food. And when you eat the food, it's actually turned into a couple of things. First, that food is taken up right by the cells and used for immediate short-term energy. So that's the first thing that happens. You get energy for immediate needs. Glucose stimulates, goes right into the tissues, and you have that. The second thing that the insulin does, it actually allows the food that isn't used immediately to be stored from the liver into glycogen, which is actually for intermediate energy. That's why for somebody like me, the day before these crazy bike rides, or the week before, I was eating a lot of pasta, because pasta has a lot of intermediate level energy that could be used for glycogen that can then be used during the activities. And then finally, if you have even extra from that, then it's turned into fat. So glucose is taken in, insulin converts it first to immediate energy, then liver into glycogen for intermediate energy, and then into fat for long-term storage. That's the absorption phase. The fasting phase. During the fasting phase, the idea is you don't have any energy coming in, and so glucagon, another hormone, is secreted, and glucagon actually allows the glycogen that you have as intermediate energy to be converted back into glucose. Sorry about all the G words. I didn't make them up, but that's the way it works. So you can actually use, during the fasting phase, glycogen converted into glucose for energy, and then the fat. The fat is also converted back into usable energy. So the idea with absorption and fasting is your body seems to be able to monitor and control how much glucose is in your system based on what you're ingesting and how it's working. So that's a very biologically based idea, and that maps up very well with B here, the glucostatic theory, page 357 of your book. The glucostatic theory basically says there's an area of your brain that monitors glucose, and that area is considered to be the hypothalamus. So the idea is maybe the hypothalamus is the one monitoring glucose levels and actually controlling all these absorption and fasting things going on. They've done some very interesting research about this with the hypothalamus. One of the more interesting projects that was done, they took a person that was very, very hungry. I think actually it was an animal study. They took an animal that was very, very hungry, and they just decided to go into the hypothalamus and put a tiny bit of glucose in there. And what they actually found is the organism chose not to eat because this receptor probably in the hypothalamus was kind of monitoring glucose, and if you put glucose right in there, it wouldn't actually try to get food. So the idea that the hypothalamus is monitoring glucose levels is also very consistent with this idea of set point theory. So set point theory says the body monitors glucose levels, will watch for them, will know what to do, and if it goes up or down, you'll actually want to eat or you won't want to eat. The second theory here that I'll share with you is called the lipostatic theory. Once again, there's information in your book, Chapter 10, on the lipostatic theory, and this came from some very interesting experiments done, I think, in the 60s and 70s, and what they basically did is they found a couple of structures up in the brain. One structure was called the lateral hypothalamus, and what they actually did is they took mice who and basically stimulated their lateral hypothalamus, and they found that when they stimulated this area, these organisms started to eat. So the idea became known that maybe the lateral hypothalamus is the feeding center, that when this area is stimulated, the lateral hypothalamus, maybe that's what causes you to start eating. On the other hand, when they went into these animals and they lesioned these areas, the lateral hypothalamus, they found that the organism lost all will to eat. So the idea of the lateral hypothalamus kind of being the feeding center was certainly part of the equation here. Okay, so the other structure in the brain that's part of this equation as well is called the ventromedial hypothalamus, on the belly, on the side of things. And once again, they did some very similar studies to this area of the brain. Once again, Powley was one of the people doing this, it says on 347. They went into the VMH, and what they did here first is they actually stimulated this particular area of the brain, and they did it when the animal was eating. So it seemed whenever they stimulated this area of the brain for the animal, this would tell the animal to stop eating. So if an animal was eating and you stimulated the ventromedial hypothalamus, it caused the animal to stop eating. In this way, the ventromedial hypothalamus came to be known as the satiety center. Satiety, S-A-T-I-E-T-Y, kind of a French word. The satiety center. The other interesting thing that happened here is what would happen when you damaged the ventromedial hypothalamus. Well, it was very interesting. When you damaged this area, all of a sudden the animals ate and ate and ate and became super, super obese. There's a picture on 346 that the idea is the animal really became super obese. And so the notion that, once again, the VMH is kind of the satiety center, and if you destroy that area, then you're basically wrecking an animal's ability to stop eating. The other interesting thing about the VMH lesion, as your book says, is it's very interesting what happens to the animals. You would think that you put any food in there and they'll start eating. Not that way at all. The animals didn't eat most of anything you put in there, but if they found a food they really loved, they ate a bunch of it. So it actually became kind of known as binge eating that would cause this particular overweight nature, and kind of a new set point once again. So the lipostatic idea was also very consistent with the notion of biology-controlled eating behavior. Now, the truth of the matter is there are a lot of other structures in the brain that are involved in eating as well. The idea that there are centers, the LH and the VMH, that's really can't be the whole picture now, but this is basically the biology of eating. So I hope this makes sense for you. Form your outline, use the book, write some detailed notes in here, and that should be good for part 1.